Most of us view farming as some kind of conscious, strategic masterstroke of human intelligence. We just assume we solved the problem of hunger through sheer willpower. But the reality is far more mundane. We didn't actually master the plant, we essentially performed an accidental 10,000-year hostage negotiation with a grass that wanted to escape us. This transition from hunting and gathering to organized agriculture wasn't a sudden epiphany. It was a biological failure of the plant's own survival mechanism that allowed us to trap it, and in doing so, trap ourselves. I'm going to explain the mechanical failure of a grass stem that changed human history. The geography of the Fertile Crescent provides the setting. This region, spanning parts of modern Turkey, Israel, Jordan, and Syria, basically functioned as an outdoor laboratory. Environmental conditions here were very specific: hot, dry summers paired with mild, wet winters. This climate pattern created the ideal conditions for annual grasses to thrive. Now, it's tempting to assume humans suddenly decided to begin farming, but evidence suggests we were processing grains long before we even had the ability to plant them. Archaeologists have identified milling operations dating back 75,000 years. Humans were already grinding seeds into flour while still living as nomadic collectors. It was a process of wandering, scouring the landscape for wild grain that was biologically designed to be elusive. Long before the construction of the first fences, prehistoric hunter-gatherers existed in a cycle of constant migration. Groups like those at the Ohalo II site, roughly 23,000 years ago, lived a life of rigorous foraging. They spent their days identifying anything edible, eventually recognizing that wheat grain provided caloric density. This wasn't a revolution in food production, it was just an expansion of the gathering list. Archaeological evidence of cereals and rudimentary bread preparation exists as far back as 30,000 BC in Europe. Humans were chewing on processed grains tens of thousands of years before they ever considered remaining in a single location. They were simply opportunistic collectors, unknowingly initiating a relationship with a plant that would eventually dictate their entire societal structure. Around 10,000 years ago, the process shifted from random collection to intentional cultivation. This wasn't a singular moment of genius, but a gradual, deliberate alteration of human interaction with Middle Eastern wild grasses. Rather than just observing the wheat, people began exerting control over its life cycle. They moved from being observers to active participants in the plant selection process. This transition occurred over thousands of years in the Fertile Crescent. We effectively traded the plant survival mechanism for our own convenience, creating a dependency that bound us to the soil. We became the custodians of a species we had inadvertently broken. To understand the mechanics, we have to look at the plant's anatomy. Wild wheat is biologically engineered to scatter its seeds. This mechanism is called shattering. It occurs at the rachis, the stem connecting the seed spike to the main stalk. The wild plant shatters to survive, dropping its grains onto the ground to propagate the next generation. Humans, however, only value the wheat that fails to do this. We selected only the non-shattering spikes for harvest. Consequently, we redesigned the species. Before sophisticated ovens existed, this process remained primitive. The earliest bread was a dense slurry of seed and water, baked on rocks in the sun. We didn't merely change the plant, we altered the trajectory of human nutrition. The process of domestication was agonizingly slow. We have evidence from 9,844 spikelets recovered from archaeological sites showing that this transition wasn't instantaneous. It required over a millennium of continuous selection to lock in the non-shattering trait. This indicates that early farmers weren't following a blueprint. They were just stumbling through generations of trial and error. Each harvest, they unconsciously favored the plants that held onto their seeds, effectively training the wheat to rely on human intervention to reproduce. This was an evolutionary bottleneck spanning 30 generations. This selection process created a significant genetic bottleneck. By repeatedly choosing the largest, easiest to harvest seeds, humans drastically reduced the genetic diversity of the wheat population. We traded the resilience of wild strains for the high yields and ease of harvest required for stationary life. This decision had lasting consequences. Wild einkorn wheat, for instance, possesses a much more complex nutritional profile than the varieties we cultivate today. In our pursuit of yield and uniformity, we inadvertently stripped away the genetic markers that allowed the plant to resist disease and drought. We created a crop that requires our constant protection to survive. This trade-off is curious. We gained caloric stability, but we sacrificed resilience. Modern agriculture rests on a foundation of varieties that are essentially clones of one another, maintained through intense human input. We often congratulate ourselves on this advancement, yet we rely on a biological system that is incredibly fragile. It is a peculiar arrangement. A species that once thrived in the wild now occupies vast tracts of the planet, yet it cannot move a single inch without our help. A stable supply of grain fundamentally altered how humans occupied space. Nomadism became obsolete when one could store a mountain of seeds in a pit. This surplus allowed for the construction of permanent settlements. Walls were erected, reserves were established. When food supply exceeds immediate consumption, time is freed for pursuits unrelated to survival. This surplus served as the engine for the rise of organized civilizations. In ancient Egypt, this scale reached its peak. They integrated tools and animals to manage the crop, turning a biological anomaly of the Rachis into the foundation for every street, government, and hierarchy. Ancient Egypt became the granary of the world. Along the Nile, bread production moved from a household task to an economic pillar. Herodotus noted that bread functioned as currency, used to pay salaries for ordinary workers and senior officials alike. It transcended simple sustenance, becoming a component of medicinal remedies and religious offerings. Preparation evolved through stages, kneading in troughs, baking on hot plates, and eventually using clay pots on embers. Yeast discovery transformed the product from a flat disk into a leavened loaf. Organized bakeries emerged, and the trade of wheat expanded as Egyptians shared their methods with the Greeks and Romans. The Greeks refined the process, developing ovens with doors and preheating capabilities. Hippocrates documented various breads and sweets, while Athenaeus recorded early flatbreads topped with vegetables, cheese, and herbs, a rudimentary ancestor to the pizza. The Romans adopted these techniques, scaling production to industrial levels. Under Emperor Trajan, the bread industry in Rome functioned as a massive 5-part system involving mills, ovens, and organized bakeries. This led to the formation of the first bakers' guilds. As the empire expanded, they absorbed new ingredients and foreign yeast strains, continuously modifying the biological output of the original broken wildgrass. Byzantine bakers focused on crumb structure, adjusting flour quality and milling techniques to create diverse products. They expanded into pastry making, incorporating honey and fruit syrups. By 1881, electricity industrialized the baking process, finalizing the transition of wheat into a standardized global commodity. From this, the modern map of flour and water emerged, the croissant of Vienna, the baguette of France, the ciabatta of Italy. It is a highly specific, curated list of items derived from a single, accidentally domesticated weed. Today, we face the limitations of this 10,000-year experiment. Geneticists are now looking backward. They are currently examining the genomes of ancient einkorn wheat, seeking the resilience and nutrient density that we discarded during the domestication process. We are attempting to reintroduce these wild traits to help modern wheat withstand a changing climate. It is a strange irony. We spent 10 millennia domesticating a plant to be dependent on us, and now, to ensure our own food security, we are forced to beg that same plant's wild ancestors for their original genes. We arrived at our current civilization by accident. We took a wild grass that was designed to shatter and scatter, and we punished it for doing so. We kept the seeds from the plants that failed to move, and we planted them again. We repeated this until the wheat forgot how to survive without us. Today, wheat accounts for approximately 20% of the calories consumed by the human species. Our entire societal architecture, our cities, our economies, our history, is built upon the structural failure of a Rachis that stopped shattering. We created a world where a plant is entirely dependent on our labor to propagate, and we are entirely dependent on the plant to eat. It is a remarkably successful, yet fundamentally fragile, symbiotic trap. Actually, the most absurd part is that we now look at the genomes of ancient einkorn wheat to see if it can save us from the climate change we've created. We've broken the grass, and now we're hoping the ghost of the wild grass can fix it.